Hi everyone, this is Math Done Right with another math video coming your way, and today we're going to look at systems of equations. So it's going to be a three-part series actually, and this is part one, and part one is going to be focusing on systems that only have one solution. And now for systems of equations we have x's and y's. Oh my. So a system, when you're looking at systems of equations, what you're really doing is solving multiple equations with multiple variables simultaneously. So we're going to have a few equations, a few variables, and we want to solve them. And there's going to be two methods that I'm going to talk about in this video. And the first method is going to be called substitution, and the second one is going to be elimination. And when I'm doing these problems, I'm going to explain why it's easier to use one method compared to the other, and how to solve this system, and make sure to emphasize that we do in fact get one solution for these problems. So here is going to be an example of method one. Substitution. So let's say my system of equations is this: 3x plus y equals 4 and 5x plus 2y equals 3. Let's say, I'm going to put some brackets around there. I'm trying to solve this system of equations. So I have two equations, right? Two variables, I have x and a y, and I want to solve them simultaneously. And remember, in this video, I'm going to get only one solution for this system. So when we're trying to do substitution, we want to look at both equations and see if it's easy to solve for either of the variables. Or I want to see if it's easy to solve for x and y in the first one or in the second one. Well, if I look at the first one, it's really easy to solve for y, right? I can solve for y, and this gives me that y is 4 minus 3x if I subtract 3x from both sides. So now what I'm going to do is I'm going to take this y, I'm going to shove it into my second equation. So now I replace this y here with 4 minus 3x, and that gives me a 5x plus 2 times 4 minus 3x equals 3. Now I have a linear equation in one variable, right? There's just an x here. So I can distribute, gather like terms, and solve for x like I've done before. So this gives me 5x plus, I have to distribute here, right? So I have 2 times 4 and 2 minus 3x. This gives me an 8 minus 6x equals 3. I'm going to gather like terms. So I have 5x minus 6x gives me negative x plus 8 equals 3. Subtract 8 from both sides, and I get negative x equals negative 5. Bring this up here. Negative x equals negative 5. Divide both sides by negative 1, and I get x equals 5. So that's part of my solution. But I still need to solve for y. I'm trying to solve for both variables here. Well, now I just take this 5 and I plug it in for x right here, because y is 4 minus 3x. So this gives me that y equals 4 minus 3 times 5, which is 4 minus 15, which is negative 11. So I get that y equals negative 11. Alright, now we're going to look at method 2, which is elimination. Now, in some cases, it's going to be better to solve a system using elimination or substitution, and I'll discuss that for this problem. What makes me want to use elimination here instead of substitution? So I have 2x plus 3y equals 0, and 4x plus 9y equals negative 2. Now, if I were to try to do substitution here, it's not easy to solve for either x or y here, or x or y here in the second equation, because I would get some nasty fraction. We all hate fractions, right? Nobody wants to deal with those. So with elimination, I'm going to try to eliminate one of these variables. And the way I'm going to do that is let's look at eliminating the x variable. And so I want to add these two equations together that cancels out the x variable. So what do I need to multiply this 2x to cancel out 4x? Well, it has to be a negative 4x, right? So if I multiply the entire top equation by negative 2 and then add them together, the x variable is going to be gone. So let me just write out what that looks like first. So if I multiply by the negative 2, I get a negative 4x minus 6y equals 0. And I have to multiply the entire thing by negative 2, right? But 0 is conveniently, 0 times negative 2 is conveniently 0 still. Now the second equation stays the same. Okay, now if I add these two equations together, I have negative 4x plus 4x gives me a 0x. Negative 6y plus 9y gives me a plus 3y. And I'm adding here. 0 plus negative 2 gives me a negative 2. And I have 0x here, right? So that's just 0. There's nothing there. And this gives me that y equals negative 2 over 3. Now I still need to solve for x. And I can choose either equation here to plug in for y and I'll get the same value. So let's just do the top one. So I'm trying to solve for x. So I have 2x plus 3. Now y is negative 2/3. That's what I just found out. So I multiply by negative 2/3 here equals 0. Now I just have to solve for x. So if I distribute this 3, or if I multiply this 3 into here, I get 2x minus 2 equals 0. And this gives me that x equals 1. So now I have this. If I were to plug in 1 into this x and negative 2/3 from this y, I would get 0. And if I were to plug in 1 and negative 2/3 here, I'd get negative 2. So these two answers, or these two numbers, x equals 1 and y equals negative 2/3, is the only solution for this system. These are the only two numbers for x and y that I can plug in to give me an answer. And that is how you do the substitution and elimination method. And these problems we're working on systems with one solution. So I hope you enjoyed the video. Make sure you watch part 2 and 3 to learn how to do infinitely many solutions and no solutions. Thanks. Bye.